Welcome back, everybody, to Math Concepts. What we're looking at today is the AdMath 2022 June exam, and we're looking at the kinematics question, and then followed by the probability and statistics. And those are the last couple questions on the paper. Every other questions that you'll see was already answered here at Math Concepts. So if you have not yet subscribed, please do so. Like, drop a comment and share these videos. All right, here we go. This question is number 5D, and it's the kinematics question, and it reads, a particle moves in a straight line so that t seconds after passing a fixed point, or its acceleration is given by a is equal to 3t minus 1 meters per second squared. When t is equal to 2, the particle has a velocity of 4 meters per second and a displacement of 6 from O. Determine the velocity when t is equal to 4. All right, what we're going to do here is to remember that we can apply integration in a context like this, since we have the acceleration. Where acceleration, velocity, should say, is equal to the integral of acceleration with time. So if I integrate acceleration with time, I will get velocity, right? So we want to apply that in order to find a function for velocity. All right, so let us go about doing that. So then in this case, we're saying that the velocity is going to equal to taking the integral of the function for acceleration here, which is 3t minus 1, and we're doing this with time, right? dt. So taking the integral, we could say velocity is going to equal to 3t squared over 2. We'll add 1 to the power and divide by the new power, all right, minus t plus c. So this is the function that will work for velocity, but definitely we need to find out what is this c here. So what we're going to use to find c is an idea that already worked. We were told that when t is equal to 2, our velocity was equal to 4, right? So when t was equal to 2, the velocity was 4 meters per second. So we're going to substitute, yeah? We're going to substitute these values here in this velocity function in an effort to find c, the constant. Therefore, we're going to say that 4 is equal to 3 over 2 t. But remember now, t is 2. So we're going to put 2 there. So 2 squared minus 2 plus c. Continue working. 4 is equal to 2 2's 4 plus that. That's 12 over 2 minus 2 plus c. 4 is equal to 6 minus 2 plus c. 4 is equal to 4 plus c. And basically, we could see here that if we subtract 4 from both sides, 0 is equal to c. So the constant is 0, which means that the velocity function is really 3 over 2 t squared minus t. All right? All right, so that's the velocity function since c is 0. Now, what we want to know now is to find the velocity at where t is equal to 4. So when t is equal to 4, I can definitely say, all right, when t is equal to 4, I could definitely find my velocity and see what we get right about now, all right? All right, so let us do that. Could do this right below it. All right, so there goes. So the velocity is going to equal to 3 over 2. T is 4 squared minus 4. So we're talking about 4, 4, 16. 16 times this is going to give us 48 over 2 minus 4. That's 24 minus 4. The velocity is actually 20 meters per second. And there it is. The velocity at 4 seconds would be 20 meters per second square. Now, if at all you have any doubts regarding your response, you could plug in, using the velocity function, you could plug in 2 to see if you really get back 4, as was stated by the question in that function. So we could just quickly just do a quick test, all right? Just in case. Remember, we were told that at t equal 2, our velocity was 4. So we're saying that, hey, let's run a quick check. That velocity should equal to 3 over 2 t squared minus t. So this would have equal to 3 over 2 square plus 2 minus 2. This is going to give us 3 times 4 over 2 minus 2. So this is going to give us 3 4 is 12 divided by 2, 6 minus 2. 6 minus 2. And definitely we got back v to before. So we see that the velocity function does work. So basically you could just find, you're able to use that velocity function to find the velocity at any time you want, at 2 seconds, at 3 seconds, at 4 seconds, at 5 seconds, whatever second you want, you're able to plug in that time in this velocity function and you will be good. So basically you would have done that and that's good enough. All right. Remember though, that this was not a part of the working. This was just to see how well the velocity function does work. And we're seeing that it does pick up back things that we knew from the question that was given. But definitely for this question, the answer is 20. All right, let's jump into some probability now and statistics. All right, all working must be clearly shown. So let us see what's going on here. The question reads, at a school canteen, 80% of the students purchase chips and 55% purchase chicken, which is K. All right, good. It says of the students who purchase chicken. So here we're getting a quick condition that of the student that purchased chicken, and we're talking about, they did say 55%. All right. So after 55 that purchased chicken, 11% out of that did not purchase chips. And this is going to be giving us the clue because this is telling us that this is chicken only. All right. So we want to look at this already and said, oh, those who purchased chicken only. All right. Because they did not purchase chips. So this section is when chicken and chips is mixed up. Those who purchase chicken purchase chips. And we have a section that purchase chips alone and a section that purchase chicken alone. So we are going to use that idea to get the responses that we want. What I'm going to do though, I'm going to work with decimals. So I'm going to put my percentages in decimal. For example, 11%, I'm going to utilize it as 0.11. That's 11 over 100 anyway. 55%, I'm going to use it as 0.55. All right, I'm just going to be working with some decimals. All right, so we were told that everything in K is 55%. Right? And in my judgment, I'm saying it's 0.55 as a decimal. Now, we were told that 11% here, 11% do not purchase chips. So I'm going to put no chips for these, which means that they're not going to be a part of that intersection there. So if they're not going to be a part of the intersection, then we're going to have to subtract. So when we do subtract here, we're talking about, I would just say 0.55 minus 0.11, and I'll get 0.44. Basically, what I'm saying is, here in the middle here is 44%, which is 0.44. All right, so I'm using decimals. So we're saying that 0.44 would be those who purchase chicken and chips. And then the 0.11 would have been those who purchase chicken only, because the fact that they said they did not purchase chips, that means it's chicken only. Now remember, we got a 80% for those who purchase chips overall. So if I know that, and I'm looking at 0.44, so 80% for me, it's a 0.8. So I'm going to say, guess what? To find 0.8 minus 0.44, that's about 0.36. Yeah. That 0.36 would be referring to those who purchased chips only. Because when I add up these numbers, I should get back my 0.8, which is 80%, and I should get back my 0.55, which is 50% when I'm looking at the circle. Remember though that everything must come to 1. So then, if everything must come to 1, we're realizing that we are not having 100% here. So some students did not purchase anything. So for example, if we say 1 subtract 0.36 plus 0.44 plus 0.11, whatever remainder we get would be that outside. All right, so 0.36 plus 0.44 plus 0.11 would get 1 minus 0.91, which is 0.9. Right? 0.09 should say, hold on. 0.09, hold on. All right, 0.09. So on the outside, I do have 0.09, which would be like a 9% if we're looking at it like that. So basically, this would have illustrated the idea. For those who want to see, this is like 36%. This is 44%. This is 11%, and this out here is actually 9%. And those are the values that I'm saying, you know. So I just had the decimal for those. So that's that. Determine the probability that a student choosing at random purchases only chicken or chips. Now, the big word here is or. The only is not the issue, it's the or. So when we have or in probability, then we are going to add the ideas, right? So or suggests that we're going to be adding the ideas. If it was and, we would have multiplied, but it's or. So we're looking for only chicken, and only chicken is 0.11. And I'm going to be adding that to only chips, which would have been 0.36. And I'm getting 0.47, which is the same thing as 47%. All right. But remember, it's a probability, so we could leave it at that, or we could say 47 over 100. All right. So any one of these. So we could use the decimal, or we could use the fraction there. So that would have been the response for that. All right, let's go. We're looking at another probability question, the B part. It says the probability of the occurrence of two events, A and B, are given by probability of A is 1/4, the probability of B is 3/5, and the probability of A union B is 7/10. Determining the probability of A intersect B. A intersect B. Now, the general formula here is that if I want to find the probability of A intersect B, it is given by the probability of A plus the probability of B minus the probability of A union B. So you could see that we got A, we got B, and we got the union. So all we have to do is to put it together. What are we talking? We're talking about probability of A is 1/4 plus the probability of B, which is 3/5. And we want to subtract the probability of A union B, which is 7/10. So at this stage, we're adding and subtracting fractions. We could just quickly go ahead and put it together. So let me draw a line here. We're talking about using 20. So 4 into 20 goes 5 times. And 5 times 1 is 5. 5 into 20 goes 4 times. 4 threes, that is 12. 10 into 20 goes 2 times, and 2 times 7, that is 14. If we do add those, 17 at the top minus the 14, I'm getting 3/20. And that would have been the probability of A intersect B. So this here is the probability of A intersect B right there. All right. So that's 3/20 for that response. All right, let's continue working the other questions. So this is a conditional probability, and it is saying, what is the probability of A given that B occurs? So we want to find the probability of A given that B has already or had already occurred. There is a quick formula for this. If I'm asked to find the probability of A given that B occurs, then the formula is that I need to have the probability of A intersect B over the probability of B. So if I can put this together, then I will quickly get that idea. So the probability of the intersection, we just found that. All right, so let's just take a quick look at it. It's 3/20. So the probability for A intersect B is 3/20, and we're supposed to divide that by the probability of B, which was a 3/5. All right, so basically, this can be looked at various ways. So let us say we want to look at this from this angle. We're talking about 3/20 divided by 3/5, which really means 3/20 multiplied by 5/3. And here we could cancel 5 into itself 1 time, 5 into the 24, 3 into itself 1, 3 into 3, 1. 1 times 1, that is 1 at the top. 4 times 1 is 4. So we're talking about the probability of A, given that B occurred, is 1/4. All right. So there it is. We would have gotten 1/4 for that probability, and then we would have moved on. Question says, state a reason whether event A and B are independent. Well, I could drop a mathematical statement here. If they are independent, so I'm just gonna just have a quick disclaimer. If event A and event B are independent, so I'm saying if they are independent, then this should occur. What? The probability of A times the probability of B should equal to the probability of A intersect B. So if this is a mathematical statement, if this works out, then they are independent. Probability of A is 1/4. The probability of B is 3/5. All right, and their intersection, we work that out to be 3/20. So let's work this out. 1 times 3 is 3. 4 times 5 is 20, which is equal to 3/20. Then here it is. So we could say that, okay, based on that language, that statement, I could say that they are independent. All right, so that's one thing or one way we could have, gone through that. So that's that. All right, let's continue working. Here we have the following table shows the marks obtained by 27 students in a math test. So we have all of those scores there. Construct a stem and leaf diagram to display this. Sorry, stem and leaf to display that. All right, let's see. If we're going to construct a stem and leaf, we're going to have some quick key here. What are my key I want to drop? I want to let it be known that if you see 3 with a 5, this means 35. Yeah. So I want to know that. So basically, my stem, this would be like tens, and my leaf is going to be ones or units. All right. So I want to make this clear. So my stem and leaf is going to be like this. So I'll have my stem here, and I have a nice line, and then I have my leaf here. All right, let me see how far I could go. All right. So basically, I'm going to start with 3. So I have 0, which is for 30, 35. There's a 39. There's a 4 for 42, 45. There's another 45. There is a 5 for 52. There's a 59. Then there's a 61. So there was a, let me draw this, continue that. There was a 61. There's another 61. If you look, there are 2 61s up there. Here is the 61. That's the first one. There's the second one. So I'm seeing 2 61. Then I have a 65. I have a 69. Then there is a 70. Then there's a 71, a 75, a 77, a 79. And then there is an 81 right there. So for the 8, I'm having an 81. 81, then 81, then 83, 83. And I have 83, 83. And then I have 87, 89, 87, 89. And then I have 90, 90, 95, 98. So we have 90, 90, 95, and a 98. All right, so that's it. So sometimes I just do a quick check to see if I have 27. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6. So if I look and I think I missed out any, like I just think I left off 1. So I'm looking quickly, 98, 95, 99, I have that, 89, 87, 85, 83. See, I left off 83, 83. So I have 283. All right, I have that. Oh, I left off 85. Good. All right, so 85 is missing. Quickly. So I normally check back. So I checked and I realized that 85 was missing. So I have 83, 83, 85, 87, 89. All right. See that? 85, 87, 89. Hold on, that's 88. 89. All right, so let's check about the 80 line. 81, 83. So 81, 83, 2 83s, yeah. Then 85, 87, 89. All right, good. So here's my all of this. So that's how we do this. You double check, and if you left off anything, you write it back easily. All right, so this is a quick stem and leaf, but we outline so that people know what the things represent, the stem and the leaf, and show the key. All right, so that's that. All right, the question says, state one advantage of using a stem and leaf diagram to display a data. Well, it's one advantage is that one is able to we could readily I want to say that we can readily identify, our mean, mode, and median. We can easily do that. Can quickly do a mean, mode, and median, and that's just one. Another thing is that the data, you don't lose any data because everything is presented. But they did say 1, so we pick 1. State the range of values of the marks obtained. So we just go back, and this is one of the quick thing too, because if I'm stating the range, I could just quickly look and I'll see 30 and I'll see 98. So I'm seeing 30 and I'm seeing 98. So my range is to subtract that. So I'm seeing 68. So quickly, my range is 98 minus 30. And there it is. I'm getting 68 quickly. So that's that. So 68. All right, so we have a box and whisker now. It says the data are displayed in the following box and whisker plot. So we're taking a quick look at that. They said state two distinct observations about the data as seen in the box and whisker plot. The moment I look at it, I could see that it is negatively skewed because this mark here is our Q2. It is also my median, it's the middle. And this is my Q3 up here. This is my Q1. This is my lowest. And this is my highest. All right. So let's quickly look at that. We could see this thing here is showing us all of that. So one, we could say this graph is this thing, the data is negatively skewed. Yeah. Negatively skewed. So we could see from the lowest to the median compared to the median to the highest. There's a huge difference. That's one. And I could just simply say it's non-symmetrical, right? So it's non-symmetrical right now. Yep. It's not symmetrical because when you look at this, look at this box here compared to this size. There's a huge difference just by looking at it. And not only that, it topples off all the way down here. So you could see that the data, you know, there's no symmetric to it. So it's non-symmetrical. That means we have a whole lot of results to the left of the median here compared to the right. All right, so there's a whole lot of results going on here, going down that side. So it's negatively skewed, it's non-symmetrical. All right, so those are just two of the things that I see when I looked at it. And this is the end of the paper. All right, as I said to you, please like, subscribe, and drop a comment at Daily Maths Concept. All right, see you next time.